This last one here, guys, is we're talking about Le Chatelier's principle. This is for, oh my God, that marker's terrible. And that was brand new. Not happy. I got ripped off. Get rid of this. My shirt is on the ground. You know, having a moment. So if you think of this again as A plus B going back and forth with C. So let's think of gases here. So this one's a special case. So if you've got gases and you've got different amounts of moles, changing the container can make a difference. So we're at equilibrium here. And you might not change the same container, you might just decide to run the reaction in a different container and you're going to get different results. So let's say we're here in a second and we're doing this. And it's a 10-liter container. Okay? If you look at this balanced equation, hopefully your eye's drawn to something. There are no numbers out in front of any of these molecules. So that means 1 mole of A plus 1 mole of B gives you 1 mole of C. So that means you have got 2 moles on this side of the equation and 1 mole on this side of the equation. So when you're finally at equilibrium, and I'm just going to do what I did last time. I'm not going to do different amounts again or different colors. 2, 3, 4, 5, and then 1, 2, 3, 4, 5. So we're at our ratio here. So we're at equilibrium, 5 pieces. And let's decide that this container is going to shrink. You're going to compress it to 5 liters. You're going to lose half the volume. You're going to push it down. Or you're just going to do the reaction in a different container. What's going to happen to equilibrium? Well, you're in a rigid container, solid sides. So it's not a balloon where, the gases are going to be able to push out and change the volume. So according to equilibrium, not that this reaction has wants or feelings, but it's going to try to keep the conditions, and as long as you don't change the temperature, it's going to try to keep it at the same pressure. Same P. What's the only way you can keep the pressure stable? Well, the only way you can keep the pressure stable is if you change the number of particles you've got floating around there. Well, how are you going to do that? Well, the only way you're going to do that is if you favor one side of the reaction over the other. Oh, well, if I've got a smaller container, the only way I can get less pressure is if I have fewer particles. Oh, but I've got a side of the equation that does have fewer particles. So what's going to happen is C is favored now. The reaction is going to push itself to C because that's the way it can get fewer particles. Okay, well, that kind of makes some sense. Well, let's think about it this way then. Let's change the scenario. If you're able to expand the container, and it could be even just 11 liters, but let's make it ridiculous. Let's make it 20 liters. What's going to happen? Well, again, you're going to try to keep things at the same pressure. That's what the system's going to want to do. What's the only way you can do that? Keep the number of, keep not keep the number of particles the same, but if you're going to keep the pressure the same, you're going to need more particles. Is there a side of the equation that gives you more particles? Yes, there is. It's the reactant side. Oh. So, with gases, and only gases, because solids and liquids are kind of infinitely concentrated. So they don't factor into this condition. You can squeeze the bejesus out of them, and you're not really going to change them a whole lot. So if you've got gases and you have different moles on each side of the equation, you can tip equilibrium. If you've got different moles on either side of the equation, the side that has fewer moles of gas will be favored by shrinking the volume. If you have different moles of gas, the side of the equation will be favored by expanding the volume. Sometimes, though, it won't make a difference. And you can see it this way, with one simple change. Now you've got 2 moles and 2 moles. You can change the volume to your little heart's content. Neither side is going to be favored. In fact, it doesn't have to be 1 mole of different gases. You can do this. That's still 2 moles of gas and 2 moles of gas. Doesn't matter that it's the same gas. 2 moles and 2 moles. Neither side is favored. You can do A plus 2B plus C, giving you D and 3E. 4 is still 4. If those are all gases, neither side is favored. So now you have a little bit better insight into Le Chatelier's principle. Okay? At equilibrium, if a system is stressed, the system will react to resolve the stress. You can mess with concentration by either adding particles and taking them away. You can mess with temperature, because reactions can be endothermic or exothermic. And if you're working with gases, you can change volume. That's it. Okay? Back with more concepts in another video.